Dear students, welcome back to the session. The topic of the session is set operations. At the end of the session, you will be able to illustrate the working of set operations on relational databases and explain the role of null values in RDBMS, that is Relational Database Management System. The most important operations that we are going to discuss are union, intersection and except. So first of all, let us discuss all these things with an example. You are going to list out the set of all courses that are taught in fall 2009 semester. In several universities, they are naming the semesters as fall and spring, and this query, you are going to write a query that is going to select all the courses which have been taught in that particular semester, that is fall 2009. So you have to find the tuples that are in the fall semester in the 2009 year. So the query goes like this. As you know, you have to have a select class which selects the particular attribute or the column from which table you are going to take the tuples, and the condition is provided in the var class, and the conditions are combined using the AND operator. So this course selects all the course ID from section relation where the condition is the semester has to be fall and the year has to be 2009. Select course ID from section where semester equal to fall and year equal to 2009. So this is like simple English language. And the next query is that the set of all courses taught in spring 2010 semester. Select course ID from section. The condition only differs where semester equal to spring and year equal to 2010. So this lists out all the courses which are taught in 2010 year, that too in the spring semester. So we have two relations which are the result of both these queries. Now we are going to apply union operation. So our objective is to find the set of all courses that are taught either in fall 2009 or in spring 2010 or both. So we have separately found all the courses which were taught in fall 2009 and separately in spring 2010. Now we are going to combine. So the query appears to be like the first subquery, that is select course ID from section where semester equal to fall 2009, and you have one more result which were the courses taught in spring 2010, and we are going to combine it using union. This is simply the keyword union that is going to combine both these things. So if at all if you have duplicates, that will be eliminated automatically. The union operation automatically eliminates duplicates, unlike the select class. The select class will bring you duplicates, but in case of union, that will remove it automatically. So this gives you the courses that were taught in either fall 2009 or spring 2010 or in both. So if you want to retain the duplicates also, then you have to replace union with union all. So this will not remove any duplicates if at all if it is present in the query result. So those courses taught in semester fall of 2009 and taught in spring 2010, that will be combined together with the duplicates retained with the help of union all. The next is intersection. So this is like finding the common thing which is present in both the relations. So to find the set of all courses taught in fall 2009 as well as in spring 2010. So the common attributes has to be selected. So you are going to use intersect. The same subquery, the query which is used to find the courses of fall 2009. The query used to list the course IDs of courses taught in spring 2010. So these two are having an intersection. So the only the common attributes or common tuples will be retrieved. Intersect operation automatically eliminates the duplicates. If you want to retain the duplicates, then you have to write it as intersect all. Similar to union all, you have to write as intersect all. The next is the except operation. This goes like set difference. To find all courses taught in fall 2009 semester but not in the spring 2010. So this except operation will give you all the tuples which are present in the first thing, fall 2009, that are not in spring 2010. So you have to use the keyword except. For all these things, we are using the same queries that are used to find the courses in fall 2009 and similarly in spring 2010. So here the keyword is except. So those courses in the first relation, that will be retained if it is not present in the spring 2010 result. The except operation outputs all the tuples from its input that do not occur in the second input. First input tuples that are not in the second input, that will be given. So this performs set difference. The operation automatically eliminates the duplicates in the input before performing the set difference. If at all, if you want to retain the duplicates, you have to write it as except all instead of except. The next part is null values. So null values when present in the tables, that will give you special problems including arithmetic operation, comparison and the set operations. So the result of any arithmetic operation that involves plus, minus, multiplication, division is null if any of the input values is null. For example, if a query has got an expression like r dot a, that is in the relation r you have an attribute a. So this is one particular attribute which is added with 5, and if that attribute is null, then the expression result also must be null for that tuple. Comparison that involves null are also problem. If you consider, you are going to compare 1 with null. If you check 1 less than null or 1 greater than null, that would be wrong if you say either true or false, because we do not know what is the exact value of null. So that is the problem with dealing with null. So SQL treats the result of any comparison that involves a null value as unknown. We do not know exactly what is there. So that's why the result is also unknown. This creates a third logical value in addition to true and false. So when you consider Boolean values, it is having only 2 values, true and false. If your result is unknown, that gives you third value. So that is not a good one. The definition of the Boolean operations are extended to deal with the value unknown. So we have redefined the Boolean operation definitions to deal with these unknowns, and the result of true and unknown is unknown, false and unknown is false. True and unknown is unknown, but with false and unknown it is definitely false, and unknown and unknown is unknown. Or in case of Boolean or, the result of true or unknown is true, whereas false with unknown is unknown, and unknown or unknown is unknown. The result of not unknown is unknown. So we do not know what is the value. That is why you cannot exactly judge what is the result. We can verify that if r dot a is null, then 1 less than r dot a as well as not of 1 less than r dot a evaluates to unknown. If the var class predicate evaluates to either false or unknown for a tuple, the tuple is not added to the result. So after checking with the condition of the in the predicate class, var class, if you could find that the result evaluates to either false, if it is false, we will not add the tuple to the result. Similarly, if the result is unknown, you will not add the tuple to the result. SQL uses a special keyword null in a predicate to test for a null condition. For example, here you are going to find all the instructors who appear in the instructor relation with null values for salary. Those who are not provided with salary, those who are having the salary field as null, that will be listed here. So select name. You are going to find all the instructors from instructor table where salary is null. So this will search whether the salary is null. If at all, if it is null, then that particular instructor name will be listed. The predicate is not null succeeds if a value on which it is applied is not null. So similar to is null, which checks for null values, you can also check for not null values using the predicate is not null. When a query uses the select distinct class, duplicate tuples must be eliminated. So whenever you use distinct, then it means that the duplicates will not be listed. So only the unique things, that is distinct tuples, will be listed. For this purpose, when comparing values of corresponding attributes from two tuples, the values are treated as identical if either both are not null or equal in values or both are null. Thus, two copies of a tuple such as A null are treated to be identical even if some of the attributes are null. So, this is the case when dealing with nulls. So, these two are treated as being identical. So, summary, we have discussed about the set operations that can be applied on relational algebra tables. So, relational tables, union, intersection and except, and how nulls are treated when taking with operations like arithmetic operations, comparison, etc. Take this as reference book. Thank you.